Good day. My name is Alan Luloff, and I'm with the Association of State Floodplain Managers, and we're here today to talk about the National Flood Barrier Testing and Certification Program. Also presenting today is Randall Boehm with the U.S. Army Corps of Engineers and Brian McDonald with FM Approvals. So the things we're going to cover today primarily are a little bit about ASFPM, talk about the National Flood Barrier Testing Program, introduce FM Approvals, and then discuss the testing and certification program requirements, the component material testing, auditing, and then performance water testing, and the value of the testing and certification program, and then discuss some of the products that to date have been tested and certified. The Association of State Floodplain Managers was formed in 1982. It's a national organization which has two primary missions, one to reduce flood losses and the other to protect the natural and beneficial functions of floodplains. To date, we have about 15,000 members. We have 35 chapters in 41 states and one Canadian province. We have 14 policy committees, one of which includes our non-structural floodproofing policy committee. These are our volunteers with our organization that man these policy committees. ASFPM established a certified floodplain manager program in 1989, and we now have about 5,000 certified floodplain managers in the United States. And one of our major functions is conduct annual National Flood Conference and then specialty floodproofing and flood mitigation workshops. It was at this one of these specialty floodproofing workshops that the National Flood Barrier Testing and Certification Program really got initiated. After a conference in 2002, there was interest in testing programs because there was need to kind of ensure quality products were being developed and to differentiate for products that obviously the ones that work and ones that don't. People were really interested in feeling the need for that. At the time, Larry Buss was the U.S. Army Corps of Engineers lead, and in conjunction with several other staff at the Corps, they developed the water testing standards based on the BSI kite mark. And the Corps funds testing funded testing for several floodplain products in 2004, and that's where the facilities got established, and their facilities in Vicksburg were established for testing these facilities. And FM Approvals created a standard, 2510, that kind of created the standard for doing this testing of these products. And then ASFPM and the Corps of Engineers began to partner with FM Approvals in 2010 to kind of develop this national program for testing and certification. And it actually got launched in 2012, so it's been in effect now for 2 years. So the basic components of the program, it's a partnership between our three entities, the ASFPM, the Corps of Engineers, and FM Approvals, and it's a kind of a dual recognition system. FM Approval has their approval process and certification process, and then there's this national program recognition, so it provides this a two-pronged recognition for these products. The requirements are basically a water-based testing that's done at generally at the Corps of Engineers facilities in Pittsburgh, component and material testing, and then there's initial and surveillance audits of the materials at their construction site, and then FM approval is issued. And then there's 3 levels of certification. Those levels are the silver, gold, and platinum levels, related to the amount of hydrostatic water depth that they've been tested and withstood that testing process. Either 1, 2, and 3 feet for each of those 3 levels. So the program is set up so that ASFPM is the program coordinator, and it's a lot of our members that are primarily interested in this certification process and to see that these products have been tested. And so we are the overall program coordinator, and then the water-based testing done for the perimeter barriers, that's conducted generally at the U.S. Army Corps of Engineers facility or Engineering Research Development Center in Vicksburg, Mississippi. And then there's also opening barriers that are evaluated at the manufacturer's facility or at a ERDC facility or at an alternative test laboratory. All testing must be witnessed by FM approvals, and then the material component testing is specifically conducted by FM approvals, and then FM approvals does a facility audit and annual surveillance auditing at where the products are manufactured to kind of see the quality control that's conducted there.
This is Brian McDonald, and let me tell you a little bit about who FM Approvals is. FM Approvals is a business unit of FM Global, which was founded in 1835 and is now one of the world's largest business property insurance organizations. It has over 100,000 insured locations in over 130 countries around the world. FM Global has over 5,000 employees, of which about 1,800 are specific loss prevention engineers. Now, what makes FM Global unique is their philosophy that a majority of all losses are preventable. You shouldn't have to recover from a loss. You should just be able to prevent it in the first place. And that's what those 1,800 loss prevention engineers help to do. They perform regularly scheduled site inspections of all of FM Global's insured facilities around the world, and they identify loss exposures. These exposures can be in the form of fire, wind, or flooding hazards. They then recommend solutions to help mitigate or even eliminate that risk. And they often do this by recommending the use of FM-approved loss prevention products. FM Global publishes advice in the form of property loss prevention data sheets. And these are essentially engineering guidelines that detail how to best protect a facility against various different types of hazards. And the data sheet that applies to flood is 1-40. And some advice that's included in this data sheet is, number one, don't build in a flood zone. Avoid it if at all possible. But even beyond that, you must ensure that the infrastructure supporting the facility is secure. If supply lines are cut off, for example, due to a flood, that will create a business interruption, which is a significant issue. Elevate everything. Elevate the building, elevate electrical equipment, communications equipment, data processing equipment, critical storage items, lift it up. Also, have a documented FERP, a flood emergency response plan, that details what everyone's responsibilities are in the event of an emergency. But it's not enough just to have a FERP. Periodic training with the plan must be conducted to ensure everyone stays familiar with their responsibilities. And another piece of advice taken from this data sheet, use FM-approved flood mitigation products. Now, FM Approvals was founded in 1886 with the primary purpose of supporting FM Global by testing and certifying loss prevention products. They're headquartered in the U.S. with 10 additional offices located outside of North America. FM Approvals has over 200 published product testing standards, all of which can be downloaded free of charge at our website, fmapprovals.com. The standard that applies to flood is our Class 2510 approval standard. And we're very pleased to let you know that this standard was recently adopted by the American National Standards Institute, so it's now ANSI FM 2510. And the requirements of the National Flood Barrier Testing and Certification Program mirror the requirements found in the 2510 standard. So a manufacturer who satisfies the requirements of 2510 can obtain dual recognition. They can be recognized under the national program and also obtain certification in the form of FM approval. The program covers temporary barriers, which are typically set up away from a building. They're fully deployed when there's a flood warning and completely disassembled and stowed away after the event. It also covers opening barriers, also known as closure devices, which protect openings in a building, such as doors, windows, or vents. And the requirements of the program include component and material testing, performance water-based type testing, and auditing of the manufacturing facility. We recognize that any product is only as strong as its weakest link. Therefore, we subject flood barrier components and materials to several tests. Pressure retaining components are subject to hydrostatic strength and leakage testing. Movement parts could be subject to durability cycle type of testing. Gaskets are subject to tensile and compression tests. Certain materials are subject to abrasion resistance. We conducted different types of environmental and corrosion testing, all to ensure that no one component is going to break down and compromise the entire system. Auditing is another critical aspect of the program. We're going to conduct an initial audit of the manufacturing facility to ensure they have the proper quality procedures in place to prove that they are capable of reproducing a product identical to the one we're testing and certifying. We're then going to enroll that manufacturer in a follow-up surveillance audit program. We're going to make regularly scheduled periodic visits to the manufacturing facility where we'll review the product and the critical documents and ensure nothing has changed, and they're still manufacturing a product identical to the one we tested and certified. Any changes must be reviewed and approved in advance. Design changes may require additional testing to prove that it hasn't impacted performance.
The water-based performance testing is primarily conducted at the Engineer Research and Development Center in Vicksburg, Mississippi by the U.S. Army Corps of Engineers under the direction of Donald Ward. This testing looks at primarily perimeter barrier water testing, and this slide here shows a plan view of a schematic of the testing facility. The shaded gray area would be where the perimeter barrier would be placed, and all tests would look at seepage or overtopping, any type of deflection in that perimeter barrier. So with this Engineer Research Development Center, the testing is based on the protocol for evaluation of expedient flood fight structures, where hydrostatic tests are performed, where we use a static water level, and then we vary the depth of that water on that structure. And then we also look at hydrodynamic tests, where we form waves, small waves 2 to 3 inches in height, medium-sized waves 6 to 8 inches in height, or large waves 10 to 12 inches in height. Additional information on the perimeter barrier water testing is that we also look at overtopping of that barrier, and we perform this for 1 hour with at least 1 inch of overtopping occurring. Then we also look at impact testing, where we take a 12-inch diameter log with a weight of about 610 pounds, and we move that directly at the perimeter barrier at 7 feet per second. And then after that testing, we increase the size of that log to 17 inches, about 790 pounds. And once again, we use a speed of about 7 feet per second and strike that perimeter barrier. And then we also run a current or a velocity test for 1 hour, where we have a maximum rated height of water plus 1 inch. And we move that velocity at that perimeter barrier at 7 feet per second to see if there's any deflection or seepage in that barrier. On the static water testing, we have 2 photos here of the water that's placed up onto the structure itself, and then again, we do the wave testing, and the photo in the lower right here is of a 1-foot wave being thrown at a perimeter barrier. This is a video of the 12-inch wave testing. And then we also perform the overtopping test. Here you can see one of the products that has the static water elevation brought to the height of that plus 1 inch. And we overtop that barrier for an hour to see if the barrier itself maintains its performance. And additionally, as I stated earlier, we do the debris impact testing, and here you can see one of the logs that is being brought at 7 feet per second to strike onto that barrier within this video clip. And as I said, this is performed with 2 different sized logs, and the results are recorded. Then on the opening barrier hydrostatic load test, the barrier's put in place. It's filled with water, and we look for a seepage on that barrier to see how well that performs. And then it is taken apart and then placed back together. And then we move into a dynamic impact load test on these opening or closure barriers, where we strike the structure itself at about 80% of the height of that structure and towards the center of it. And then we will see how well that performs. And then we will again strike the closure very close to the sill. We will take the structure down and then redeploy it, fill the basin again with water, and see how well it has handled these impact load tests. And our next slide here should have a series of photos showing that impact load testing occurring.
I'd now like to spend some time illustrating the value that the testing and certification under this program brings. Without testing, it's very difficult to determine if a product's going to work properly. Here are 2 very similar looking flood barriers, and if you were able to inspect them, you'd see that they are both solid construction, secure, with seemingly good gasket material. You may think that either one will provide adequate protection. However, we tested them both, and the one on the right passed, but the one on the left failed with a leakage rate of 7.5 gallons per hour, which is 6 gallons over our requirement for this particular barrier. Our seepage rate criteria for this type of barrier is 0.08 gallons per hour per linear foot. And this is a 12-foot barrier being tested against 3 feet of water. So the linear footage is 3 feet here, plus 12 feet here, plus another 3 feet here, for a total of 18 feet. Multiplying that by the 0.08 criteria gives an acceptable leakage rate of 1.5 gallons per hour. The good news is that this manufacturer made some design changes and retested and then achieved passing results and got certified under the program. Component and material testing is very important as well. Here are the results of an abrasion test conducted on material samples from 3 different bladder tube type barriers. For this test, an abrasion wheel is passed back and forth across the sample 3,000 times, and it can't break through the material. The top 2 passed, the bottom 1 failed. Now these tube-type barriers, they get dragged across various different types of terrain. They get stepped on, they get beat up during the deployment process, and they need to be able to withstand a certain degree of abrasion. Now testing is important, but it doesn't stop there. If a barrier isn't installed properly, it's not going to do what it's designed to do. And flood barriers are often installed by local contractors who don't really have an understanding of how flood products are intended to operate. And over the next several slides, I'm going to show examples in which barriers were improperly installed by local contractors. And then I'll also call attention to some additional requirements of the National Flood Barrier Testing and Certification Program that will help alleviate these concerns. Here's an installed flood door, and at a glance from the outside, everything looks fine. However, if you were to look from the inside of the door, along the bottom, you can see daylight. And if you can see daylight shining through, you can be sure that water is going to come through. Now, it turns out that the contractor didn't install the strike plate in accordance with the drawings, and the latch doesn't allow the door to be pulled tight against the seal. Here's another similar example to the one on the previous slide. Again, a flood door installed by a local contractor who didn't follow the provided drawings and instructions. The strike plate wasn't installed properly, nor was the sweep on the bottom of the door. Both played a role in why this door didn't have a good seal. Here's an example of a swinging gate in which daylight can be seen between the bottom of the gate and the floor. In this example, I'd like to show you the importance of proper operation and maintenance of a flood barrier. The first thing to be aware of are the channels installed on the correct side of the opening. These channels have a vertical gasket that provides the seal right here. If they're installed wrong on the wrong sides of the opening, the gaskets won't be in the correct location and won't form a seal. The next thing we notice is one of the gaskets is torn. These gaskets are the most critical features of the flood barrier. They need to be regularly inspected and properly maintained. Now the flood barrier is then installed to completion and everything may look fine, but looking at the picture on the left, you'll see that these planks have a textured face and a non-textured face. This non-textured face goes towards that vertical gasket. That creates the seal. This top plank is installed backwards. Now this does two things. First, it creates a potential leakage path right here. And then it's also going to damage that vertical gasket as it's slid into place. And additionally, looking at the planks on the right, these planks must be the proper length and also must be positioned correctly within the channels. You can see that this top plank isn't even making contact with that vertical gasket. Certification under the national program can help alleviate these issues because it requires manufacturers to produce two critical pieces of documentation. The first is a design, installation, operation, and maintenance manual, which does just what it says, provides details on how to properly install, operate, and maintain the barrier, with additional guidance on how to repair or replace components as needed. The second is a post-installation acceptance checklist. This is a checklist that must be completed and signed off by whoever is installing the barrier. It indicates that they have inspected critical aspects of the installation, and a copy of the completed checklist is then sent back to the manufacturer's facility where it must be kept on file. FM Approvals has issued a bulletin to all of our auditors worldwide calling attention to the post-installation checklist requirement. During the manufacturer's routine surveillance audit, the auditors will be verifying that a completed checklist is on file for all installed certified barriers.
Well, this is Alan Luloff again, and I just like to highlight that the major challenge we're facing is that we have a high demand for reliable flood mitigation solutions. Floods aren't reducing in frequency; they're getting more common, and so the demand is there for these type of solutions to these problems. The opportunity is that now with this program, manufacturers have a means to obtain a unbiased third-party certification through the National Flood Barrier Testing and Certification Program. And as you can see, it's conducted. It's a rigorous testing protocol, and it identifies the major benefits these manufacturers can prove that their products are quality products that meet the standards of this program. Again, it's a partnership of our three entities, the U.S. Army Corps of Engineers, ASFPM, and FM Approvals. We have created a website that provides information on the program, and that can be found at www.nationalfloodbarrier.org. And if you go to that site, you'll see the basic components of the program. It provides the introduction, overview, roles and procedures, and product categories. You can see here now that these products categories that have been established to date are for temporary barriers and closure devices. In addition, on the websites, you can then go there and identify under the temporary flood barrier products page those components that have been tested and certified under this program. So you can see here, Aquafence is an approved product, and U.S. Flood Control 42-inch, their Tiger Dam is an approved product also. So you can see the two major products that are listed on this page at the moment. So the Aquafence is one of the manufacturers that has a device approved. You can see the installation at the facility, the type of device it is set up, and this is actually in the state of New York, I believe, that was constructed to protect this facility here. And so you can see that it varies in the type of barriers that have been certified under this program. Another barrier is the U.S. Flood Control or Tiger Dam. Again, you can see the types of products vary, but they all have gone through the same protocols and testing requirements. So you can tell that under this program, you can see that even though these two devices are very different, that they both met the standards under this program. So again, here's a listing of the programs. This is now the closure devices that have been approved, and there's two primary manufacturers that have their devices approved. That's Press-Ray and PS Doors, and you also click on here and get the actual test reports and the certification that's been approved. There's been Press-Ray. There's 6 approved barriers. And here's photos of the types of devices that have been tested and approved under this program for Press-Ray Corporation. Here's the two others that were approved for Press-Ray, and then here's the ones that have 3 approved opening barriers for PS Doors, basically doors and then a plank device. Again, these are really valuable installations for structures that cannot be, located out of the floodplain. These are kind of on-site flood-proofing devices that can be used. And these are some quotes from manufacturers that are kind of highlighting the value of the program. It takes a lot of guesswork out of people that are caught in a flood fighting situation, and they can depend upon this certification and know that devices they select can meet the needs for their situation when they're under stress. These are a series of quotes by some of the manufacturers showing us that how they believe the value of this testing program. We're very pleased to have this program put in place, and again, the manufacturers supporting the program is evidence of at least their opinion of the value of that program. We're really appreciative of the efforts done by FM Approval and the Corps of Engineers to work with us to get this program implemented. We think it's a great value to the people that are dealing with flood issues in the United States. So thank you very much.